Okay, next, out of all the energies, there are two energies that you need to be able to calculate in the combined science syllabus: kinetic energy and gravitational potential energy. Half mv square for kinetic energy and mgh for gravitational potential energy. Again, this tells you a story, right? That kinetic energy, what matters is the mass, and how much energy it has is the mass, depends on the mass and its speed. Right, so the higher the speed, the more kinetic energy. So that's what kinetic energy is about. It's energy that is moving, so speed, right? And then gravitational potential energy is energy that is stored. Potential energy means energy that is stored due to gravity or due to its height. So it depends on three things: its mass, the gravitational acceleration, and then the height of the object. So of course, in different planet, G is different, so there's a different amount of stored energy due to its height. Okay, so this is the story that this tells. Of course, just using it is pretty straightforward. A bullet of mass 0.0500 kg passes through a piece of wood and slows from 500 to 200. So I have a bullet, right? It's gonna hit a piece of wood. It goes through. Okay. Here it's going at 500 meters per second. Here it's going at 200 meters per second. So what's the kinetic energy lost by the bullet? It's really just KE initial minus KE final, right? So KE initial minus KE final equals to half mv initial square minus half mv final square. Yep, so just sub that in. 0.05000. My v is 500 square minus half 0.0500, 200 meters square, sorry, 200 meters per second square, and this would give me 5250 joules. Alright, so this is application of the formula, so answer C. Question 13. A girl is exercising by doing the step-ups. The bench is 40 cm high, her mass is given, so M is here, H, they tell you that G is here, so they ask you gain in gravitational potential energy when she steps up on the bench. It's really straightforward, so gain in GPE equals to mgh. Okay, M is 60 kg, gravitational field strength is 10, which is good. Alright, H is 40 cm, but you know, when you use formulas, you need to use SI units in order to get the unit of joules. So 40 cm must first be converted to meters. So this is the part where you have to be careful when you're making your calculations using formulas. Make sure you're using SI units. Alright, so this should give you 240 joules. Okay.